Hi, so I wanted to make this video to clarify how the power board should be interacting with the other subsystem boards on the rover. In previous meetings, I told you guys that I wanted the power board to directly supply power to each of the subsystem boards, but after talking to Khalil today, I realized that this design would be a lot safer way of supplying power without causing too much stress on the power board itself. So I also want to add that this is a very high level diagram. I'm omitting a lot of stuff for the sake of this explanation. And if you have any questions, please message me on Slack or contact me at our next general meeting in person. So you see on the left right here, we have our battery, which is in line with a fuse rated for 100 amps. And then directly after that, we're connecting to our communications, which includes our ubiquity, which is receiving commands from mission control, our access point, which is wirelessly communicating with the ESP32s on each of our subsystem boards, and then our network switch, which is connecting these two together via Ethernet. We're also connected to the power board. And the reason that these two are connected before the rest of the preventative circuit components in here is because we really do not want to lose power to these things or at the same time or after we lose power to these. If we lose connection to communications, then mission control is dead in the water because it can't communicate with the rover. And if we lose connection to the power board, then we can't prevent anything bad from happening to these boards. So that's why we have these connected before the rest of this stuff. So right after that in the line, we have the shunt resistor, and then it's connected to a relay, and then that's connected to a non-invasive current sensor. And you'll notice all of these are going into the power board, which I'll explain in a second. So right here we have VBus, and that's connected to each of the subsystem boards. And you'll notice the other unique connection that each of these boards is receiving is a cable from the ESP32, and that's going to be our enable for whatever voltage regulators you need on board. So the VBus and the enable will be connected to as many voltage regulators as you need. So if you need a 3v3, a 5 volts, and or a 12 volts, you just need to add these. So with regards to how we're designing the subsystem boards, the fundamental difference now from what I told you guys previously is that instead of supplying direct power from the power board, you're now going to receive two inputs, one from VBus and then a enable pin from the power board's ESP32. So that's it for these. We're now going to go over to the power board. So for power board, you'll notice that VBAT is directly connected in here as I mentioned earlier, and then it's going into a buck converter, which is stepping it down from its range of like 29 to 21 volts into 3v3, which then the ESP32 can be powered with. That's also connected to our non-invasive current sensor. However, 3v3, as our current sensor's VCC, is dependent on if we get a current sensor that is rated for that. Some of them do receive 5 volts, but I'm assuming 3v3 for now. If you go back up to VBAT's connection, it's then connected to a voltage sensor, which output is connected to an ADC pin on the ESP32, and then it's also connected to a Coulomb counter. As a reminder, a Coulomb counter triggers an interrupt on its vSense pin every single time a certain fixed number of coulombs transfers through a device, and right now you'll notice that its Vin is connected to a shunt resistor right here, or the beginning of the shunt resistor mentioned earlier, and then its Vout is connected to the other side of the shunt resistor. So every time a fixed number of coulombs, I forgot how many it is right now, every time that many goes through it, an interrupt is triggered, and then we'll use this to measure how much power or voltage is left inside of the battery. And then also, I don't think I mentioned this, but of course the voltage sensor is measuring how much voltage is being used by the subsystem boards. So going back up to VBAT's line right here, it's then connected to a shorting block, which is shorted by a physical kill switch. This is a large button that we will have on the rover, and by default, when this thing is disengaged, this connection is shorted. So when this thing is not pressed down, then power is allowed to be flown through to the relay, which allows all of these boards to be powered. When this thing is pressed down, in the case of emergency, like the arm going on fire or something like that, that will open this circuit, and then that will prevent any other power going from the battery into these boards. So this is our onboard safety mechanism to prevent anything happening poorly to these boards themselves. On the other end of this relay's input right here is a MOSFET, and the gate right here is connected to the ESP32. So this will be the remote way that we can turn on and off subsystem board power to the from the communications devices. So mission control can send a command to put high or low this GPIO pin, and depending on what that is, it'll allow this relay to be closed or open because of the MOSFET right here. And then the last thing inside the power board that I wanted to mention is the non-invasive current sensor. And that is pretty simple. Like I said, you gave it a VCC, and then on the output, that will be a scaled down version of how much current is going through. So there's a relationship between this like output right here and then the amount of current being drawn through this device. You'll notice also that I have right here a voltage divider, and the reason I have that is because this will output a range of 0 to 5 volts. However, the analog inputs of the ESP32 can only receive up to 3.3. So as a result, we have to scale that down, which is why we have the voltage divider right here. I also have a Zener diode for 3.5 volts, just in case anything bad happens here that's unexpected. This will make sure that it brings it to something that we can actually throw into the ESP32. Yeah, so that's really it. So just as a cap or a summary, the subsystem boards are going to change now to receive a VBus as well as a enable coming from the ESP32 on the power board, and yeah, that should be it. So let me know if you have any questions, and I will throw this draw.io schematic inside of our team drive. Thanks.